A function and its inverse have a property we haven't talked about yet. And that property comes from when we compose f inverse with f and f with f inverse. Remember, with composition, the order is very important. And when we compose them either way, we just get out what's called the identity function with it, which is just x. So what we're saying is that f inverse composed with f of x, which would be plugging f of x into f inverse, should just give you out x. So when you do that composition and you simplify it, you should just get x. And f composed with f inverse of x, so plugging f inverse in for f, it will also give you x. And this is one way that you can check to see if two things are inverses of each other, if they undo each other. If you try both compositions, do f inverse composed with f and f composed with f inverse, both of them should just give you out x. Okay, so this says, given that f of x equals 8x plus 5, use compositions of functions to show that f inverse of x equals x minus 5 over 8. So what we need to show is that f inverse composed with f of x, that we just get out x, and we'll do f composed with f inverse. So f inverse composed with f, that means we start with f inverse, and everywhere where we see an x, we're going to put parentheses, and inside that we're going to put f, which was 8x plus 5. So now if we simplify, up top we have 8x plus 5 minus 5 over 8. Well, the plus 5 and the minus 5 just cancel each other out. So we have 8x over 8, which is just x. So far so good. We can't stop yet, but if that wasn't x, we could already say they're not inverses of each other. But so far we're good. Okay, now we need to check f composed with f inverse of x. So we're going to take f, which is 8x plus 5, and where the x is, we're going to plug in f inverse, x minus 5 over 8. Now this is like 8 over 1, so the 8's cancel out, and we have x minus 5 plus 5. The negative 5 plus 5 becomes 0, we just get x. So here, both directions, doing f inverse composed with f and f composed with f inverse, when we simplify, we just get x. So that means they are inverses of each other. Okay, one more time we want to look at the graphs of a function and their inverse. So it says find the inverse of the given one-to-one function and sketch both on the same coordinate system. So we're going to sketch both of them here. So here's our function. So remember to find f inverse. We're first going to switch we're going to put in y. Now we're going to switch the x and the y's. Now we need to solve for y. So first I'm going to add 4 to both sides. So x plus 4 equals 1/2 y cubed. Now to get the y term by itself, I need to multiply both sides by 2. And we'll distribute the 2, so we'll have 2x plus 8 equals y cubed. And now, since we have y cubed, to solve for y, we need to take the cube root of both sides. So here we have y equals the cube root of 2x plus 8. So we'll say f inverse of x equals the cube root of 2x plus 8. Okay, so now we're going to graph both of these. First I'm going to put in 1/2 x cubed minus 4. And we can think about that as a transformation of x cubed, right? The 1/2 times the x cubed, that would be a vertical shrink by 1/2, and the subtract 4 would go down 4. So and this looks like it's crossing it too. Okay, so there's the sketch of our graph, 1/2 x cubed minus 4. Then we have the cube root. We'll do it next. So to do the cube root, you can hit math, and it's number 4 here. So the cube root of 2x plus 8 and that would be like the cube root of x. You've the plus 8 would move it to the left 8, and the 2 in front of the x would compress it horizontally by a factor of 2. And we can see, let's draw this one in red, that it looks like this. Okay, and remember we said that this is a function and its inverse are reflected across the line y equals x. And if we draw that here in green, it's this line that goes just like that, and you'll see it's reflected. And to put it, since my hand-drawn graph might not show it perfectly, let's put just x there, and we'll make it a little darker. And you'll see that it runs right through it, that it's a reflection across that line.